Lesson 8.4.14, Substitution, Solving Systems of Equations Using Substitution. In this lesson, we'll solve systems of equations using substitution. All right, this is the last lesson of our unit on solving equations and systems of equations. Normally, we'd be on page 200 in your notebooks. I've adjusted the notes just a little bit from what's actually in your notebook, so you might want to go to Schoology and print out the new and improved notes. I think they're improved, that I'm going to be using here. So our learning target today is to solve systems of equations using substitution. You've already kind of done this, actually. We're going to go into it in a little more detail. Solve systems of equations using substitution. Now, let me start by just introducing something that you already know. Highlight it here in yellow just to say this is nothing new. This is just what we're basing this solving technique on. So when we know what a variable is equal to, like right here, I can see that y is equal to 4. What that means is we can substitute the variable with that known value of 4, and then we can continue to solve the equation. So if I know that y equals 4, then wherever I see y, I can substitute in that thing that y is equal to, 4. So I could rewrite this equation and write 2x plus 5, but instead of writing y, I can write what y is equal to. It equals 10. So when I rewrote that equation, I just used substitution. I substituted something that I knew y was equal to. And then you would just continue solving for here for x. But the substitution's what's important here. Now, what we're going to do, what's important to this lesson, we're still just substituting what that variable is equal to. We just don't know it as a specific value. This is all the good new stuff that I'm highlighting in pink. So we can use the same process in a system of equations. I have a system of equations here. Here's 2 equations in the same variables. If one of the equations is of the form y equals an expression, or even x equals some expression, if I know that y equals something or x equals something, then we can substitute that variable with an equivalent expression, just like we would do if we knew what the value was. Let me show you how this works. So I'm going to look at these 2 equations and ask myself, is either of those equations already solved for x or solved for y? And this first one is solved for y. I know what y equals. Y equals 5x. So that means in the other equation, wherever I see y, I'm going to substitute in what y is equal to. Just like I did up here. When I knew y was equal to 4, I substituted in 4 for y. Here, I know that y is equal to 5x, so whenever I see y down here, I'm going to substitute in 5x, because that's what y is equal to. So let's go ahead and do that. So since y is equal to 5x, we can substitute 5x in for y into this other equation. So 2x minus, here we are at y, but I'm not going to write y. I'm going to write what y is equal to. It's equal to 5x. And then I'll just finish writing the equation. Once we've got it substituted in, then we can solve for x. Let's combine these like terms. 2x minus 5x is negative 3x. I can divide by negative 3 on both sides. Negative 3 divided by negative 3 cancels to 1. I'm left with 1x equals negative 3. Now you know by now that in a system of equations, this is only half the solution. I need to still find the value of y. But now I know what x is. Once I know what x is, we can calculate y using either of those original equations. I'm going to use the first one. So in this original system, I knew that y equaled 5x. Here it is. I just found out that x was equal to negative 3. So y is equal to 5 times negative 3, because I just found out that's what x was equal to. All right, I think I have everything I need to write my solution. The x and y values together that make both equations true are known as the solutions to the system of equations. It's important to write the x value first in your coordinate and the y value second, because that's how coordinates work. And there's my solution. So the trick with substitution is that one of the equations needs to be solved for x or solved for y. And then I'll just substitute that expression whenever I see the variable in that other equation. We're going to do a couple of practice problems down here at the bottom just to get the hang of it. And I'm going to recommend that you grab a highlighter. I think that helps you to see a little more clearly what's going on. Let's look at this first one. I'm going to zoom in just a bit. Now remember, substitution works when one of these equations in the system, here's my system of equations, when one of those equations is either solved for x or solved for y. It needs to either say x equals or y equals. And I can see that this one says x equals 2y. So wherever I see x in this other equation, I'm going to write 2y instead. So let me just go through this second equation and highlight where it is that I see x. There it is. And now let's rewrite that equation, but I'm not going to write x. I'm going to write what x is equal to. So I just did the substitution right there. I substituted 2y for x. And now we can just go along and solve it. I'm going to combine these like terms. 2y plus 1y is 3y. Let's divide both sides by 3. Those 3's cancel to 1. I'm left with 1y equals 1. I'm not done. I need to come back. Don't forget. You still need to find the other variable. So I can choose either of these equations, but I like the one that I highlighted, x equals 2y. And I'm going to use what I just discovered about y to find x. I discovered that y was equal to 1. So I'm going to come up here and say x is equal to 2 times this value that I found for y. 2 times 1. So I found the x value, I found the y value. Let's write the solution to the system as a coordinate. Now, just because we found y first doesn't mean I'm going to write it first in a coordinate. Coordinates always start with x and end with y. So if y is equal to 1, I got to put it right here. If x is equal to 2, that's the first number in my coordinate. If I were to substitute that into either of these equations, it would make those equations true. Take a look at one more example together. I think this one's a little trickier. You'll see why, but I'm going to ask myself again, which of these equations is solved for x or solved for y? This one's solved for y. So wherever I see y in this other equation, I'm going to write something else. So let me find y. Here it is. I'm going to rewrite this equation, but when I get to this pink stuff that I highlighted, I'm not going to write y. I'm going to write this expression that y is equal to. Let's do it. So we have 4x plus 3 times, I'm not going to write y, I'm going to write what y is equal to. But I'm going to be putting this in parentheses because I got to make sure I multiply that whole expression by 3, not just the first term. Equals negative 15. So this is really 3 times y. I just replaced the y with this expression. All right, so let's go ahead and solve this. I'm going to simplify first by distributing the 3. I can simplify some more by combining these x terms. I'm going to use a balancing move to get my x term alone. Subtract 6 from both sides. I'm left with 7x. The 6 is canceled to 0. Equals negative 21. And now let's divide by 7 to find that x is equal to negative 3. Now remember, we're not done. Don't forget. We still need to find y. I'm going to go back. I can use either of these equations, but I'm going to go to the one I highlighted here. It's usually the easier one. And I just found that x was equal to negative 3. So I'm going to drop that right in here for x. X is negative 3. And then y is negative 3 plus 2. And I'll write my final answer as a coordinate. X is negative 3, and y is negative 1. So that's how we use substitution. And it's all based on something that you were doing before, but it was just a number that you were substituting in instead of an expression that you were substituting in. You'll need to print out the practice assignment tonight if you were absent in school. Good luck with this.